question about tunability of the nanostructured materials is very important for a variety of applications. And I can give an example in terms of light-emitting diodes that are used for solid-state lighting. So one of the challenges in the field of development of these type of devices is to produce light that is comfortable for our eyes, for human eyes. What that means is that we are trying to mimic the light that is similar to the sunlight, that has the same intensity of different colors as the sunlight itself. And the question how to develop the materials that will have exactly this type of light emission is particularly important. One way to achieve this is to produce the devices that will emit light that is green, blue and red at different ratios. By tuning the composition and the size of the nanostructured materials that we are developing, we can tune exactly what will be the band gap of the material and consequently what will be the light, what will be the wavelength of the light that that material produces. So this would be one particular example where tuning the material will tune the device itself. Another example that is also related to light-emitting diodes would be to, instead of using different colors of light that are produced, we can produce devices that are very, very efficient in producing blue light. And that blue light is then transferred and transformed into different other lights or different wavelengths of the light, red and green, at different proportions by using so-called phosphorus materials. And then again, by changing the composition and other properties of that material that transforms the blue light into other wavelengths of the light is particularly important. And we are also working on understanding how this transition happens and what are the properties of the materials that transform the light have to be. So one of the things that is still a challenge in the field of nanostructured materials for applications as light-emitting diodes for solid-state lighting is controlled synthesis. So we have a great knowledge in the field of two-dimensional films about how to achieve doping in these materials, how to control their composition. However, one of the challenges in nanostructured materials is how to achieve the same level of the material synthesis control. And this is exactly the question that we are trying to answer in my group. And the only way how we can achieve this is by having unique growth systems, which we developed in my group, as well as in developing nanostructured characterization techniques. What that means is that we are also at MIT developing characterization techniques which allow us to directly correlate the structure of the material, understanding, for example, how the composition or the morphology or the defect of the material changes its optical properties. So these are the main challenges that we are trying to address. So bridging this gap between two-dimensional conventional technologies and something that is tailored on the nanoscale is one of the important factors that we are developing.